Question 1 tells us about these two boys, Sam and Jeremy, that have ages that are consecutively odd. The product of their ages is 783. Which equation could we use if we want to find Jeremy's age, which they're using J to represent, and they're telling us Jeremy is the younger man. So, if their ages are represented by consecutive odd integers, I'm going to think about this as I have a first consecutive odd integer, I have my second consecutive odd integer. I'm going to use x to represent the first, x would be what we would normally use, but they told us to use j, so we'll use j and j plus 2. Make my little consecutive integer chart. Okay. Next thing they tell me is that the product of their ages is 783. So if I take j and I multiply it by j plus 2, I set that equal to 783. Product tells me to multiply, and they tell me what that is equal to. This is not an option. However, this equation could be used to solve for j. They went a little bit further and distributed. So if I distribute the j, I would get j times j, which is j squared, plus 2 times j is equal to 783. Now, choice 1, they don't have the j next to, so they didn't correctly distribute. Choice 2 and 4 are not correct because instead of using j plus 2, they used j minus 2, which would be a consecutive integer, but they told me j represents Jeremy, who's the youngest. So I can't use j minus 2 because that would mean Sam is younger than Jeremy. So choice 3 is my only option here to represent the equation I could use to solve and find Jeremy's age and Sam's age. Question 2. I have a quadratic, 9x squared minus 81 equals 0. They want me to find the solution set, meaning solve for x. First thing I always look for when attempting to factor a quadratic is a GCF. There is a GCF here of 9, so if I factor that out, I'm left with x squared minus 9 equals 0. Now I ask myself, is this dots or tram? Well, since it's two terms, it could be dots. It is, so I can go one step further. X times x is x squared. 3 times 3 is 9. Dots always factors to 1 positive and 1 negative, plus 3 minus 3. Now I need to actually solve this. So 9 is never going to be 0. So that goes away from my solution possibilities. X is negative 3 or x is positive 3, choice 4. This looks like I chose choice 3, but that's just my equals 0 in my equation. All right, question 3. Jordan determines that the roots of the function of g of x are negative 8 and 1. Meaning, roots are my x-intercepts, my solutions. So I have solutions of negative 8 and positive 1. If I want them back in factored form, which is what all of my choices here look like, I need to get that number back on the same side with x, and I need to set both of those factors equal to 0, so when I multiply them, I can set their product equal to either 0, or in this case, they told us it was called g of x, so we could rename it g of x equals x plus 8 and x minus 1, which is choice 2. Question 4 tells us here's the graph of a quadratic. What are the zeros? So again, zeros, same idea as roots or x-intercepts. So where does this graph cross the x-axis? I see an x-intercept at 1 and an x-intercept at 2, 3, 4, 5. So x is equal to 1 and x is equal to 5, which is choice 3. Okay, question 5, review topic. We have volume is equal to 1/3 base squared times height. They want me to take this formula, which is the volume of a square pyramid, and solve it for the positive value of b. I need to get b by itself. So if I rewrite this, my goal here is to solve for b. I'm going to start by multiplying both sides of my equation by 3 so I can get rid of this fraction. 3 is the reciprocal of 1/3. If I multiply by a reciprocal, I get 1. Now I want to get rid of the multiplication of h with my b squared term, which again is the term I want to solve for. So to undo multiplication, I would divide. Right over here. So 3b divided by h is equal to b squared. Now we're a little bit more familiar now solving these types of equations. This is quadratic. To undo a square, I would need to square root. Normally, I would put a plus or minus when I put a square root into an equation. However, they said just the positive value. So I don't have to worry right now about the plus or the minus. I'm just dealing with a positive square root. So b is equal to the square root of 3v over h, just positive square root. Choice 3. Question 6 tells me that a bag of Doritos in a vending machine costs $1.50. The cost of a bottle of water in the same machine is $2. So chips cost $1.50, water costs $2. David has $19 to spend on both chips and water, and he has to buy he must buy 10 bags of chips. They tell me B represents the water bottles. Which inequality would represent the maximum number of bottles he can buy, knowing he has to buy 10 bags of chips? Okay, well, if he's buying chips that cost $1.50, and there's 10 that he has to buy, if he adds to that the $2 he has to spend on every water bottle, which they don't tell me how many, so I'm going to label that B, he only has $19 to spend. So he can spend a maximum of 19, meaning he'd be happy if he spent less, he'd be fine if he spent 19, but he can't spend more than 19. Now I just need to look for my choice. That matches up with choice 1. Question 7, what is the equation of the line that passes through the point 3, negative 7, and has a slope of negative 4 over 3? So again, we're using this equation, y equals mx plus b, n being my slope, and b being my y-intercept. So they tell me the slope already, so I know the equation is going to be y equals negative 4/3 x plus some b. So automatically I can get rid of choices 3 and 4 because they have slopes that are not equivalent to negative 4/3. By giving me that point of 3, negative 7, I can plug in an x value of 3 and a y value of negative 7 to isolate b. So if I plug negative 7 in for y and I plug 3 in for x, all I need to now solve for is my missing b, which is my y-intercept. If you multiply negative 4/3 by 3, it becomes negative 4. Add over that 4. Negative 7 plus 4 is negative 3. So now I know the equation would be y equals negative 4/3 x minus a y-intercept of 3. Negative 3. So this choice is choice 2. And question 8. Gardener has a rectangular garden. It measures 8 by 12 feet. So I'm going to give myself a picture of my rectangular garden. He plans to increase the garden of the area. He plans to increase the garden of the field by 10%. And he will do this by increasing the length and width by the same amount. Which equation would represent the new area? Okay, so if the garden is what's inside of this field, and he wants to increase the garden by 10%, that really means we want to increase this area by 10%. I'm also increasing the length and width by the same amount x. I'm going to draw my new rectangular garden with a longer length and a longer width. And instead of having 12, it's going to be 12 plus x. And instead of having a dimension of 8, it's going to be 8 plus x right on this side because I have a little bit more room. My original area, if I had taken 8 and multiplied it by 12, I would have got 96. Well, I know that this is going to be increased by 10%. So my new area can't be 96. So I'm automatically getting rid of choices 1 and 3 since they're both set equal to my old area. Another way to do this question, even if I didn't know what to do with the 10%, 105.6 must be 10% more than the area of 96. And the way you would get that in the calculator would be that you could either take 96, times it by 0.1, and then add that number to 96, and that's going to give you the 105.6. I'll show you that in the calculator. The other way you could do that would be to multiply the number by 1 plus 0.1, and it does it in one step. So if you want to know what 10% of 96 is, you multiply it by 0.1. If you take 96 now and add that 9.6 number to it, you get the 105.6. Another way to do that, I know you've learned this in the past, is you add the percent in decimal form to 1, multiply it in one step, and you can get to the 105.6. So that gives me my area. But even without being able to figure that out, I should have known that 96 could not be the area anymore because that was the old area. I need a new one that's 10% more. That gets me to choice 2 and 4. Now, with my dimensions, they're being increased by the same amount. If you look at choice 2, this dimension's being increased by 2x, this dimension's being increased by 1x, that can't be right. So by process of elimination, we can get choice 4, or if you knew what to do with the 10%, another way to get yourself to choice 4. Question 9, we're given a function f of x as 4 points. Which point would be used to find f of negative 1? Well, f of x means what's inside function notation is an x value. So if they're giving me f of negative 1, they're telling me x is equal to negative 1. So where is that happening on my graph? Well, here's negative 1. I go up, I don't see a point. I go down, and I see the point D. So D is telling me when x is negative 1, y is actually negative 2, since this is the point negative 1, negative 2. Question 10, which graph represents the solution to these inequalities? So first thing I look at is both of these symbols are greater than or equal to, less than or equal to, so they should both be solid lines. That doesn't really help me narrow this one down because all 4 choices have solid lines, but that is a good way to start. This first inequality has a y-intercept of 3 and a slope of 1. So if I go to my line that has a y-intercept of 3, I could kind of just check to make sure they're graphed correctly. But this line in all 4 examples is graphed correctly. It has a slope of positive 1 and a y-intercept of 3. So now what I need to look at is which ones are shaded correctly. So if I plug in that checkpoint of 0, 0 to my first inequality, is 0 greater than or equal to 0 plus 3? Is 0 a number greater than or equal to 3? No, that's false. So this line that I graphed in blue should not have shading towards 0, 0, meaning the shading should go away from it. So in choice 1, I can see the shading goes away from it, so this one's still a possibility. In choice 2, the shading does not go away from it. I can see that it's going down, which is not what I want. Choice 3, the shading is also going down. Again, not what I want. Choice 4, it's going up. So just by knowing how to figure out the shading, I was able to get it narrowed down to choices 1 or 4. Take a look at my second inequality. I want to look at all 4 graphs. They all seem to be graphed the same. They all have a y-intercept of negative 2, and if you look closely at their slopes, they're all going down to right 1, which is the slope of negative 2. So they're all graphed correctly. So now what I'm hoping to discover is which one is shaded correctly. At this point, I don't really need to be looking at 3 and 2 and 3. I'm just really focusing on 1 and 4. So if I plug in that point of 0, 0, is 0 less than or equal to negative 2 times 0 minus 2? Is 0 less than or equal to negative 2? That's also false. 0 is a bigger number than negative 2. So I'm looking for the graph to, again, not be shaded over this point of 0, 0. If I look at choice 4, it is shading over 0, 0. That's incorrect. Choice 1 is shading away from 0, 0. This is the only one that is graphed correctly for both of my inequalities. Okay, question 11. Which point is not on the graph represented by y equals negative 3x plus 6? Quickest way to do this question, go to your calculator. Let's type this into our y equals. So I have the equation y equals negative 3x plus 6. Let's go to the table, and I'm looking for one of these ordered pairs to be there. To not be there, excuse me, which is not on the graph. So I'm looking at the first point was given to me as 4, negative 6, and I see that, so that is on my line. I'm looking at the point 2, negative 3. I do not see that. So that is going to be my choice. But again, let's just confirm negative 3, 15 and negative 4, 18 to confirm that they are indeed there. I would go up towards the negative numbers just to show you that you can check all of these points. Negative 3, 15 is right here, and negative 4, 18 is right here. So all 3 out of those 4 choices are on the line, except for choice 2. 2, negative 3 is not on this line. Last question, when factored completely, what is this expression equivalent to? So again, in terms of factoring, we first look for GCF. There is nothing in common between p to the 4th and negative 81 except for 1. Then I look for, is it dots, if there's 2 terms, or is it some type of tram? Now, p to the fourth minus 81 is two terms, so it can't be tram, so it must be dots. So now I look for what times itself gives me p to the fourth, or what is the square root of p to the fourth. If I cut that exponent in half, I get a 2. Then I look at the square root of 81, I'm going to get a 9. So I go to rewrite this as p squared plus 9, p squared minus 9. Again, no matter what method it is after GCF, you always check for dots again. Is it dots again? Well, I never look for the plus sign to be dots because dots stands for difference of two perfect squares. But I am going to look at this p squared minus 9 since it has a difference. Could this be dots again? I take the square root of p squared, cut that exponent in half, I get p to the first. Take the square root of 9, and I get 3. So to completely factor this, I would have to bring down the p squared plus 9 and factor the p squared minus 9 into p plus 3 and p minus 3. I cannot factor this because this is the sum of two perfect squares, which we do not have a factoring method for with real numbers. So choice 3 is the only choice completely factored. Okay, question 13. We're being asked to solve for x. So again, just like in question 12, we went through those possible factoring methods. First thing I'm going to look for is there a GCF? There is a GCF here of 5. So I'm going to factor that out. And if I divide 5x squared by 5, I get x squared. If I divide 125 by 5, I get 25. Keeping that minus sign in between. Now, there are two terms, so then the next thing I ask myself is, can I go further with dots? And I can. X squared breaks down into x times x. 25 breaks down into 5 times 5. Again, with dots, you should have 1 plus and 1 minus. I am now fully factored because when I ask myself, is it dots again, in this case, it's not. Because this minus sign, x minus 5, this cannot be factored further since the 5 is not a perfect square and the x to the first is not a perfect square. So when you've determined you've done all methods, you take your factors and you set them equal to 0 and you solve for x. 5 can never be 0, so we just kind of get rid of that whole thing. X plus 5 equals 0, which means x is equal to negative 5. X minus 5 equals 0, which means x is equal to positive 5. So I get two solutions, which is what we should get when we solve a quadratic equation. Question 14 asked you to take j of x, which is a trinomial, to k of x, which is a binomial, and find their product. Again, product tells you to multiply. When you multiply polynomials, just to make things a little easier for yourself, it's nicer to put the smaller polynomial to the left. It's less to distribute. If I use the distributive method, I'm going to first start by distributing this x term. So x times x squared is going to give me x to the third. X times negative 2x is negative 2x to the second. X times 3 is positive 3x. Now I'm going to distribute a 1, and the only thing that happens when you distribute a 1 is everything really stays the same. So 1 times x squared is x squared. 1 times negative 2x is negative 2x. 1 times 3 is 3. To fully answer this question, after you multiply, you do have to combine like terms. There's only 1x to the third term, so there's nothing to combine with that. There are two terms that have an x squared, and there are two terms that have an x to the first. There's only one constant term. So when I go to write this in simplest form, x to the third stays itself. If I take a negative 2x squared and add it to a positive 1x squared, I have negative 1x squared. Take a 3x and a negative 2x, I should have positive 1x. And again, that 3 constant term has nothing to combine with. It stays 3. Question 15 also is asking us to solve a quadratic. However, this factoring method is going to be a little bit more involved since I have a number in front of my leading term that is not equal to 1. Again, you still look for a GCF, but in this case, 2, 3, and negative 9 do not share anything in common other than 1. So I'm stuck with that 2 in front. So I'm going to start by taking that 2 and taking this negative 9, and I'm going to multiply them and get negative 18. Then I ask myself, what multiplies to negative 18 and adds to 3? If you're not sure, you go to your calculator, you type in the number you're trying to find the factors of, which in this case is negative 18. You divide it by x and go to your table. I'm looking for two numbers that will also add to positive 3. and I see them here, -3 and +6. If I add them, will get me to +3. If I multiply them just from seeing them in this chart, I know that they multiply to -18. Come back to my question. After finding your numbers, that is going to split your middle term into two terms. So I have that 6m and that -3m. The order in which you write them will not change your answer. Your next step just might look in the opposite order. Okay, so when we factor by grouping, split it down the middle. Let's GCF factor the left. I'm going to take out a GCF of 2m, which is going to leave me with 1m plus 3. And on the right-hand side, my goal is to get m plus 3, which are both positive. Right now I have two numbers here that are negative. So when I take out that GCF of 3, I'm going to take it out as a -3 so that I can end up with two positive terms of m and +3. Don't forget we're solving an equation here, so each step of the way I should still have my equal 0. The next step, this m plus 3 binomial is common on both sides, so I need to factor that to the front. And what I would be left with is the 2m and the -3. Again, it helps you to think about it. You take the common binomial, that goes in your answer once. The leftover pieces come together to be your other factor. I know I'm completely factored because I look at both of these binomials. Neither of them are the difference of two squares, so I'm ready to just take my two factors, set them equal to 0, and solve for m. My first solution is going to be an m of -3. My second solution is going to take two steps, add the 3, then divide by 2 to get either 3/2, or you could write this as 1.5. Question 16. From here on out, these questions were worth a little bit more. They're worth 6 points. So question 16 says, at Ron's Rental, a person can rent a big screen television for $10 a month plus a one-time wear and tear fee of $100. So that's the information they give me about Ron's Rental. At Josie's Rental, they charge $20 a month and an additional charge of $20 with a no wear and tear fee. They're telling me in the question to use C for cost and M for months. Then it goes on to say, okay, create a system of equations representing how much each rental company charges. And then we'll graph at the end. So as you're watching this video, this is a review topic of systems of equations. This will be on the quarterly. Okay, so for Ron's Rental, again, using C for cost, that's my Y. Using M for months, that's my X. I even labeled it for you so you can see which one's X, which one's Y. C is equal to, if it's $10 a month, that would be 10M plus that one-time fee of $100. And then for Josie's, the cost is equal to $20 a month plus a $20 fee. Get rid of that for now so I have room. Okay, so your first step had to be write out that system. Once my system's written, they want me to solve this graphically, so I am going to plot each of these. So I'll do them each in a different color. Let's start with Ron. So they have a y-intercept of 100 and a slope of 10. So if I look on my y-axis, every box represents 10. And I look on my x-axis, everything's going over by 1. So I can go up one box to represent 10, over one box to represent 1. So up 10 over 1 is really up one box, over one box. So if I plot these points, up 1, over 1, it's going to get me all the way up here. I'm going to plot my line. Using the smartboard, just give me a second. I'll make sure it's straight. And I'm going to label this. I can either label this with the equation, or you could have labeled this by simply writing Ron. Now I'm going to plot Josie's rental company. So this, for Josie's, we have a y-intercept of 20. So I'm starting here. My slope is 20 over 1. So I need to go up 2 boxes over 1 box. So up 2 over 1. Then plot as many points that will fit on your grid. I can now see their intersection point. Back up a little bit here so I can plot my last point. And using a straight edge will help you greatly with things like this. And again, labeling. You must label when you graph more than one thing on a grid. So if you did not label, you automatically lost a point. Now, the follow-up question did ask to determine and state the number of months in which Josie's cost will be the same as Ron's. So this ordered pair of my intersection point is 8, 180. So the 8 is my M, which in this case is acting as my X value, and the C is cost for Y. So after 8 months, both of these companies will cost $180, so you had to indicate down here 8 months. If you wrote the whole thing, 8 months will cost $180, that's fine, but you had to write 8 months to get full credit on this graphing. Question 17. A school is building a rectangular soccer field. It has an area of 6,000 square yards. So I'm going to just start by drawing myself a rectangle and indicating that area. The soccer field must be 40 yards longer than the width. So the length of the soccer field is 40 yards longer than the width. So I'm going to let the width be X. If you label the diagram, you don't technically need the let statement as well, but you need one or the other. So both is not necessary, but you need the let statement or the picture. I think the picture is more helpful because it gives you the visual. Now, in terms of area, they tell me it's 6,000 square yards. I know area is length times width. So in terms of what I have here, my length times my width is going to be equal to that 6,000 square yards. They want me to determine the dimensions, meaning they want me to actually determine the length and the width. And it does tell me here that only an algebraic solution receives full credit. So if you guess and check on a question like this, you get 1 point. This is worth 6. So you have to show your work. So x times x is x squared. X times 40 is 40x. It's equal to 6,000. Now I'm going to subtract that 6,000 over so that we can attempt to try and factor this. So x squared plus 40x minus 6,000 is equal to 0. Now I don't expect us to figure these numbers out maybe right off the top of our head. So let's go to the calculator. I'm going to type in negative 6,000 divided by x, go to my table, and I'm going to scroll. Oh, negative 6,000 divided by x. So I'm looking for numbers that are going to add up to positive 40. So just looking at these numbers, right now there's major differences happening here. I'm nowhere near these numbers adding to 40. So this one did take you a little while to scroll. Again, we're looking for whole numbers, so I might pause here. I see whole numbers of 40 and negative 150, but still I'm at a difference of negative 110. I need to keep going. And I see some more whole numbers, 60 and 100. If I subtract those numbers in the right order, I can definitely get to 40. If I want the 40 to be positive, instead of positive 60, negative 100, I'm going to use positive 100 and negative 60. So x plus 100, x minus 60 equal to 0. Solve to get both of these factors equal to 0 gives me solutions of negative 100 and positive 60. Now, if this was just a question that you were solving for x, both of these answers would solve the equation. However, it's coming from a real-world question that x represents the width of a field. So we can't have a negative width, so I'm going to reject the negative. And remember, x only represents the width. They want me to find the dimension, so I need to indicate either by showing it on my diagram or writing a separate sentence that the width is 60, which makes the length 60 plus 40, which comes out to be 100. You had to find both dimensions in order to get full credit. Last question. John and Sarah are both saving money for a car. They tell us that the total amount of money John will save is given by this function, f of x, and the total amount of money that Sarah will save is given by this function, g of x. They're asking us after how many weeks x will they have the same amount of money? So I want to know when this equation is going to equal this equation. So in order to figure that out, I need to set them equal to each other. So let's set x squared plus 46 equal to 60 plus 5x. X represents weeks, So if I solve for x, I will figure out how many weeks it will take for them to earn the same amount of money. So I'm going to get everything equal to 0. I get x squared minus 5x minus 14 is equal to 0. Asking myself now what multiplies to negative 14 adds to negative 5, and that's going to give me a negative 7 and a positive 2. Again, if you have trouble with that, type into your y1, negative 14 divided by x, and look at your table. When I go to solve these, I get an x of positive 7 and an x of negative 2. The negative 2, again, x represents weeks, so I can't have negative 2 weeks, so I need to reject the negative. X equals 7, which means in 7 weeks, they will have the same amount of money. Now, this is almost full credit. This is worth 5 points out of 6, but it did ask me to explain how I arrived at my answer, not explain how many weeks it takes for them to earn the same amount of money. So just writing 7 weeks is not enough information. To explain how I arrived at my answer, I need to say something about what I did with my algebra. So I'm just going to simply state I set the two equations equal to each other and solved for x. And that was enough to get full credit. So anytime we see this word explain, we need something in words. If it's said to justify, then just your math is enough.